So today we discuss increasing and decreasing functions. How to determine the given function is increasing or decreasing using differentiation. What is the use of differentiation? To find increasing or decreasing functions. What is the definition? Geometrical definition is, let f of x be a real valued function defined an interval I contained in the domain of f of x. Here f of x is a real valued function defined in the interval. Then f of x is said to be increasing on the given interval I if this condition is satisfied. x1 is less than x2, f of x1 is greater than or equal to f of x2 for all x1, x2 belongs to I. Strictly increasing on I if x1 is less than x2 implies f of x1 is greater than f of x2 for all x1, x2 belongs to I. Decreasing on the given interval if this condition satisfies, that is height of the graph at x1 is less than or equal to height of the graph at x2. Strictly decreasing on I if x1 is less than x2 implies f of x1 is less than f of x2. Right. So observe the graph. Suppose take this graph. So this is the graph of f of x. Here take 2 points on x-axis, x1 and x2. As we move left from origin along x-axis, the values are increasing. Here x1, x2. Here clearly x1 is less than x2. x1 is less than x2. As we move along graph from left to right along the graph, the height of the graph f of x1, height of the graph at x2, f of x2. So clearly the height of the graph is continuously increasing. So therefore this function is strictly increasing on the given interval I. If x1 is less than x2, f of x1, that means height of the graph is less than, strictly less than height of the graph at x2, the function f of x is said to be strictly increasing function. In this graph, as we move from left to right along the graph, the height of the graph is increasing. Sometimes they are equal. Height of the graph at these 2 points, height of the graph is same. So height of x1 is less than x2. Sometimes f of x1, height of the graph is equal to height of the graph at x1 is equal to height of the graph at x2. Or if x1 is less than x2, f of x1 is less than or equal to f of x2. So if f of x1, height of the graph at x1 is so less than or equal to, less than, greater than or equal to, greater than. So height of the graph at x1, is less than or equal to height of the graph at x2, the function is increasing. F of x1, height of the graph is f of x1 at x2, this is the height of the graph, is increasing, therefore the function is increasing. Sometimes they are equal, f of x2 and f of x3 sometimes equal, that's why height of the graph at x1 less than or equal to height of the graph at x2, then the function is said to be increasing. Strictly increasing, when we say the function is strictly increasing on the given interval I, strictly increasing means if x1 is less than x2, height of the graph at x1 is strictly less than height of the graph at the point x2. F of x1 is strictly less than f of x2, the function is said to be strictly increasing on the given interval I. Decreasing function, when the given function is decreasing and strictly decreasing. If x1 is, suppose take 2 points, x1 and x2, x1 is less than x2, f of x1, height of the graph at x1 is greater than height of the graph at x2. That means as we move along the graph from left to right, the height of the graph is continuously decreasing, therefore the function is strictly decreasing function. So observe this graph. Sometimes the height is same, but as we move from left to right, the height of the graph is decreasing, and sometimes they are equal. Suppose if x1 is less than x2 and f of x1 is greater than or equal to, first height is greater than or equal to second height, then the function is said to be strictly decreasing. So f of x1 is less than or equal to f of x2 if x1 is less than x2. The function is said to be increasing function. Strictly less than second height, the function is strictly increasing. Height of the graph at first point is greater than or equal to height of the graph at second point, the function is said to be decreasing. Height of the graph at first point is strictly less than height of the graph at second point x2, the function is said to be strictly decreasing on the given interval I. So this is a geometrical definition. Suppose in this interval, sometimes the height of the graph is increasing, after that decreasing, so decreasing, after that increasing. So in this interval, sometimes the height of the graph is increasing and decreasing, so this is neither increasing nor decreasing. So this is an example of neither increasing nor decreasing function. Next, what is the definition of a given function is said to be increasing or decreasing using differentials? What is the meaning of dy by dx geometrically? What is the geometric meaning of dy by dx? Dy by dx is slope of tangent to the curve y is equal to f of x. If the given function is y is equal to f of x, slope of, suppose this is the given function, slope of tangent, this is the tangent to the curve y is equal to f of x, slope of this tangent is dy by dx. The geometrical meaning of dy by dx is slope of tangent to the curve y is equal to f of x, right? So another definition, let f of x be continuous on closed interval a comma b and differentiable on the open interval a comma b, then f of x is said to be first one, increasing on the closed interval a comma b, strictly increasing on the open interval a comma b if f dash x derivative of given function is greater than 0. Next, decreasing on the open closed interval a comma b, strictly decreasing on the open interval a comma b if f dash x is less than 0. Third point is, if f dash x is equal to 0, then f of x is called a constant function. So this is the function is said to be increasing or decreasing depending on f dash x, that means slope of tangent to the curve. Here dy by dx or f dash x value is positive, the function is increasing. Dy by dx value is negative, the function f of x is said to be decreasing on the closed interval, strictly decreasing on the open interval a comma b. Suppose if f dash x is 0, then the function f of x is called a constant function. Once again, here the derivative dy by dx value is positive, the function is increasing in the closed interval a comma b, strictly increasing on the open interval a comma b. If f dash x, that is dy by dx value is negative, the function f of x is said to be decreasing on the closed interval a comma b, strictly decreasing on the open interval a comma b. Suppose if f dash x is equal to 0, then the function f of x is said to be constant function. So this is the very very important definition. Next, exercise 6.2. Right, exercise 6.2, question number 1. Show that the function f of x, function given by f of x is equal to 3x plus 17 is strictly increasing on real numbers. Show that the function given by f of x is equal to 3x plus 17 is strictly increasing on the real numbers. Your given function is f of x is equal to 3x plus 17 for all x belongs to real numbers. So the given interval is set of all real numbers, that is open interval minus infinity comma infinity. Set of all real numbers is the open interval minus infinity comma plus infinity. To find the increasing, the given function is increasing or decreasing, we need to find f dash x value. So first find f dash x. F dash x is equal to derivative of 3x is equal to 3 plus derivative of 17 is 0. So f dash x value is positive for all which is greater than 0 for all x belongs to R. For any real number x, f dash x value is a constant. This constant is always greater than 0. So therefore f dash x is greater than 0 for all real numbers. Therefore in the given interval, therefore function is said to be f of x is strictly increasing on real numbers because real numbers is open interval. Next, question number 2. Show that the function given by f of x is equal to e power 2x is strictly increasing on real numbers. Your given function is f of x is equal to e power 2x. Differentiate with respect to x. Derivative of f of x is equal to f dash x. Derivative of e power 2x, composite function. Derivative of e power u is equal to e power 2x into derivative of 2x is 2, that is 2 into e power 2x. Next, in any real number x, 2 is positive, e power 2x is positive because exponential function is always greater than 0. So which is greater than 0? Since e power 2x is greater than 0 for all x belongs to R. Take any real number, exponential function cannot be negative and cannot be 0. Strictly exponential function value is greater than 0 for any real number x. Take any real number. Suppose x is equal to 0, e power 0 is 1, so that is greater than 0. Take any value, that value is always positive only. So therefore here 2 is positive, e power 2x is positive for any real number x. Therefore 2 into e power 2x is greater than 0 for all x belongs to R. So therefore f of x is strictly increasing on the given interval set of all real numbers. Next, question number 3. Show that the function given by f of x is equal to sin x. F of x is equal to sin x is first one, strictly increasing in the open interval 0 comma pi by 2. Second bit, strictly decreasing in the open interval pi by 2 comma pi. Third one, neither increasing nor decreasing in the open interval 0 comma pi. So these are the three questions. Right, first, here given f of x is sin x, so differentiate with respect to x. Derivative of f of x is f dash x is equal to derivative of sin x is cos x. In the first question, in the open interval 0 comma pi by 2, f dash x is equal to cos x. Cos x is positive or negative, which is greater than 0. Since cos x is positive in first quadrant. Here cos x 0 to pi by 2 means, so between 0 to 0 pi by 2, between 0 to pi by 2, that is the first quadrant, pi by 2 to pi second quadrant, pi to 3 pi by 2, that is third quadrant, 3 pi by 2 to 2 pi, that is fourth quadrant. In first quadrant all silver teacups. So in first quadrant cos is positive, that is f dash x is greater than 0 in this interval. Therefore f of x is strictly increasing in the interval 0 to pi by 2. Next, b, in the interval, in the open interval pi by 2 to pi, that is in the second quadrant, cos x is negative, f dash x is equal to cos x. Cos x is negative, since cos x is negative in second quadrant. So therefore f of x is strictly decreasing in the open interval pi by 2 comma pi. Third one, in the open interval 0 comma pi by 2, f dash x is positive, and in the open interval pi by 2 comma pi, f dash x is negative. So therefore here in the interval 0 comma pi, f dash x is both positive and negative, So because 0 to pi means first quadrant and second quadrant. In the first quadrant f dash x, that is cos x, is positive. In the second quadrant cos x is negative. In the interval 0 comma pi, between 0 and pi, sometimes cos x is positive, sometimes cos x is negative. Therefore in the open interval 0 comma pi, f dash x is both positive and negative. This means what? The function f of x is neither increasing nor decreasing in the open interval 0 comma pi. So this is the third question. Right, question number 4. Find the intervals in which the function f given by f of x is equal to 2x square minus 3x is, first one, strictly increasing, second bit, strictly decreasing. Question number 4, 5, 6, very important. So question number 4, find the intervals, that means find the values of x. Intervals nothing but find the values of x in which the function f of x is strictly increasing, f of x is strictly decreasing. For what values of x? F of x is strictly increasing. For what values of x? F of x is strictly decreasing. Let us see. Your given function is f of x is equal to 2x square minus 3x. Differentiate with respect to x. To find the values of x, when the given function is increasing or decreasing, we need to find the f dash x value. Here find f dash x is equal to derivative of 2x square is equal to 4x minus derivative of 3x is equal to 3. So f dash x value is equal to 4x minus 3, that is equation 1. So on putting f dash x is equal to 0, we get some value of x, that is 4x minus 3. F dash x is equal to 4x minus 3 is equal to 0. Here 4x is equal to 3, x is equal to 4 by 3. The point x is equal to 4 by 3. Actually the given function is polynomial function. Domain of polynomial function is set of all real numbers. So this is set of all real number line minus infinity to plus infinity. The point x is equal to 4 by 3, x is equal to 4 by 3 divides the real number line into two open intervals, minus infinity comma 4 by 3, 3 by 4. Minus infinity comma 3 by 4, open interval 3 by 4 to infinity. Therefore the point x is equal to 3 by 4 divides the real line into two disjoint intervals, namely open interval minus infinity comma 3 by 4 and open interval 3 by 4 to plus infinity. Now let us draw a small table. Interval sin of f dash x, nature of f of x. So we have two intervals, minus infinity comma 3 by 4 open interval 3 by 4 to infinity. So take any number between minus infinity and 3 by 4. Take any number. Suppose if you take minus 1, x value is equal to minus 1, f dash x, sin of f dash x. F dash x value is 4 into minus 1 is minus 4, minus 4 minus 3 is equal to minus 7, which is negative. Sin of f dash x is negative. For any value between minus infinity and 3 by 4, f dash x value is negative. So if f dash x is negative, nature of f of x, function f of x is strictly decreasing. Negative, f dash x is negative, f of x is strictly decreasing. In the interval 3 by 4 to infinity, take any number between 3 by 4 to infinity. Take suppose x is equal to 2. So f dash x value is 4 2s are 8, 8 minus 3 is 5, which is always positive. So therefore take any number between 3 by 4 to infinity, f dash x, sin of f dash x is positive. F dash x value is positive, nature of f of x is strictly increasing. So therefore conclusion is, first question, for what values of f of x strictly increasing in this interval. So in this interval, open interval 3 by 4 comma infinity, f of x is, therefore f of x is strictly increasing. In open interval 3 by 4 to infinity, strictly increasing. Strictly decreasing in the open interval minus infinity comma 3 by 4 and strictly decreasing in the open interval minus infinity comma 3 by 4. So in these values f of x is strictly increasing, in this interval f of x is strictly decreasing. So this is the fourth question. Question number 5. Question number 5. Find the intervals in which the function. Question number 5. Find the intervals in which the function f given by f of x is equal to 2x cube minus 3x square minus 36x plus 7 is strictly increasing and strictly decreasing. So this is the question number 5. First find f dash x. Here given f of x is equal to 2x cube minus 3x square minus 36x. Find f dash x. F dash x is equal to derivative of 2x cube is 6x square minus derivative of 3x square is equal to 6x minus 36. Here take 6 common, x square minus x minus 6. So factors minus 6, 2 3s are, middle term sign is negative, biggest is negative, smallest is positive. So therefore 6 into x square minus x minus 6, the factors are x plus 2 into x minus 3. So this is f dash x. Here put f dash x is equal to 0. We get the points on real number line. F dash x is equal to 0. So implies f dash x is equal to 6 into x plus 2 into x minus 3 is equal to 0. Here 6 is not equal to 0. Implies x plus 2 is equal to 0 or x minus 3 is equal to 0. So that implies x is equal to minus 2 or x is equal to plus 3. Therefore the points x is equal to minus 2 and x is equal to 3 divides the real line into, suppose this is the real number line, minus infinity to plus infinity, minus 2 plus 3. So 1 2 3 sub intervals. So real number line into 3 disjoint intervals, namely open interval minus infinity comma minus 2 comma open interval minus 2 comma 3 and open interval 3 comma infinity. So these are the 3 intervals. So these 2 points x is equal to minus 2 and x is equal to 3 divides the real number line into 3 intervals, namely minus infinity, open interval minus infinity comma minus 2 comma 3 and 3 to infinity. So draw a table. Interval, sign of f dash x, nature of f of x. So we have 3 intervals, minus infinity comma minus 2 comma 3 comma infinity, right. So take any number between minus infinity and minus 2. Suppose minus infinity minus 2, take one number. If you take x is equal to minus 3, f dash x value 6 is positive, x plus 2, suppose x is equal to minus 3 plus 2 is negative, second factor is negative, and third factor is x is equal to any number between minus infinity and minus 2. Take any negative number, x is any negative number, minus 2 and minus 3 or minus 4, minus 3 or minus 5, minus 3, that value is always negative. So total plus into minus is minus into minus is plus, plus into plus is plus. This is positive. So f dash x is positive in this interval. Therefore f dash x is positive in this interval. Nature of f of x is strictly increasing, strictly increasing. Minus 2 and plus 3. Suppose if x is equal to 0, minus 1 or 1, take any value. Suppose x is equal to 0, here 6 into 0 plus 2 is positive, 0 minus 3 is negative, plus minus. Here 6 is, take any value between minus 2 and 3. 6 is positive number, minus 2 and minus 2 and plus 3, between minus 2 and plus 3 take any value. X plus 2 is positive and x minus 3 is negative. Suppose if we take x is equal to 1, 1 plus 2 is 3, 1 minus 3 is negative. So total plus into plus is plus, plus into minus is minus, this which is negative. Total f dash x is negative, strictly decreasing in this interval. 3 to infinity. So take any value. Suppose 4, 5, 6, take any value. 6 is positive, x plus 2 is positive, take any value greater than 3. So this value is also positive. Plus into plus is plus. So that is strictly increasing. So therefore f of x is strictly increasing in the open interval minus infinity comma minus 2 and 3 to infinity. 3 to infinity open interval, and strictly decreasing in the open interval, strictly decreasing in the open interval minus 2 comma 3. So this is, so strictly increasing in these two intervals and strictly decreasing in the open interval minus 2 comma 3. So this is very important in the examination. Next, question number 6. Under the question number 6, there are 5 questions, A, B, C, D, E. So take any 2 questions. So I will take D and E. 6th, D. Find the intervals in which the function f given by f of x is equal to 6 minus 9x minus x square is strictly increasing, is strictly decreasing. Find the intervals. Same type question. Right. F of x is equal to 6 minus 9x minus x square. Differentiate with respect to x. Derivative of f of x is equal to f dash x. Derivative of 6 is 0 minus 9 minus 2x. So this is f dash x. So put f dash x is equal to 0. We get the point or the values of x. So minus 9 minus 2x is equal to 0. 2x is equal to minus 9. X is equal to minus 9 by 2. The point x is equal to minus 9 by 2 divides the real line into 2 subintervals, 2 disjoint intervals, namely, so this is the real number line minus infinity and plus infinity, with the point minus 9 by 2 divides 2 open intervals, that is minus infinity comma minus 9 by 2 and open interval minus 9 by 2 to plus infinity. Here the given intervals are so 2 intervals minus infinity comma minus 9 by 2 and minus 9 by 2 comma plus infinity. So take any number between minus infinity and minus 9 by 2. Minus 9 by 2 means minus 4.5. Minus 4.5 and minus infinity. Take x value is equal to minus 5. X is equal to minus 5. So minus 9 minus 2 into x value is minus 5. That is minus 9 minus of minus plus 10. So is equal to plus 1 is positive. So in this interval f dash x is positive. Therefore strictly increasing. F of x is strictly increasing. Minus 4.52. Take any value between minus 4.5 to infinity. Suppose x is equal to 1 ತಗೊಂಡ್ರೆ, if we take x is equal to 1, minus 9 minus x value is 1, that is minus 9 minus 2 minus 11. So is negative. Take any value between minus 4.5 to infinity, f dash x value is always negative. So therefore strictly decreasing. Therefore f of x is strictly increasing in the open interval minus infinity comma minus 9 by 2, and strictly decreasing in the open interval minus 9 by 2 comma plus infinity. In these intervals increasing and decreasing. So the sixth d bit, f of x is equal to x plus 1 whole cube and x minus 3 whole cube. Find the intervals in which the function f given by f of x is equal to x plus 1 whole cube into x minus 3 whole cube is strictly increasing and strictly decreasing. So this is E, sixth E. Your given function is f of x is equal to x plus 1 whole cube into x minus 3 whole cube. F dash x is equal to, using u into v formula, first function into derivative of second function, derivative of u to the power of 3, that is 3 into x minus 3 whole square into derivative of x minus 3 is 1, plus second function x minus 3 whole cube into derivative of x plus 1 whole cube is using composite function, chain rule. So 3 into x plus 1 whole square into derivative of x plus 1 is 1. Here what is common? X plus 1 whole square is common and x minus 3 whole square is common and 3 is also common. So take 3 into x plus 1 whole square and x minus 3 whole square. Remaining x plus 1 whole square, take outside, remaining is x plus 1, 3 is common, x minus 3 whole square is common. X minus 3 whole square is common plus x minus 3 is remaining and 3 is common, x plus 1 whole square is common. So that is 3 into x plus 1 whole square into x minus 3 whole square into x plus x, 2x minus 2. Again 2 take outside, 2 3s are 6 into x plus 1 whole square into x minus 3 whole square into x minus 1. So this is equation 1, f dash x. Here put f dash x is equal to 0. Implies 6 into x plus 1 whole square x minus 3 whole square into x minus 1 is equal to 0. So 0 divided by 6, 0 by 6 is 0. Here x plus 1 whole square is equal to 0, x minus 3 whole square is equal to 0, or x minus 1 is equal to 0. So that is x is equal to minus 1, x is equal to 3, x is equal to plus 1. So therefore the points x is equal to minus 1, x is equal to 1 and x is equal to 3 divides the real line into, so real line minus infinity comma plus infinity, minus 1 plus 1 plus 3. So 1 2 3 4 sub intervals into 4 disjoint intervals. Minus infinity comma minus 1, minus 1 comma 1, 1 comma 3 and 3 comma infinity. So these are the intervals, right? So we have 4 intervals. One is minus infinity comma minus 1, minus 1 comma 1, 1 comma 3 and 3 comma infinity. Right. If you take any value between minus infinity and minus 1, if you take x is equal to minus 2, 6 is positive, 6 is positive. Next, x plus 1 square of any number for any value of x, x plus 1 whole square, this is a square number, is positive, and x minus 3 whole square is also positive, square number is always positive. X is equal to, between minus infinity and minus 1, x is negative, negative minus negative value is always negative. So total plus into plus into plus is plus into minus is minus, f dash x value is negative. So therefore in this interval strictly decreasing. Next, between minus 1 and plus 1. So minus 1 and plus 1, take suppose x is equal to 0. 6 is positive, square number is positive, square number is positive, plus, plus, and between minus 1 and plus 1, take x value 0. So for example, 0 minus 1 is minus 1 is negative. So total plus into plus into plus into minus is negative. Again strictly decreasing. 1, 2, 3. 1, 2, 3, suppose between 1 and 3, so take one value, x is equal to 2. So first is positive, first 3 always positive, first 6 is positive, square number is positive, square number is positive, only we observe the last factor. So x is equal to 2, 2 minus 1 is 1 is positive. So therefore total plus into plus into plus into plus is positive, strictly increasing. 3 to infinity, first is positive, second is positive, third is positive. So 3 to infinity, so between 3 to infinity, suppose if you take 4, 4 minus 1 is always positive, so that is positive, strictly increasing. So therefore here f of x is strictly increasing in open interval 1 comma 3 and 3 comma infinity, strictly decreasing in open interval minus infinity comma minus 1 and open interval minus 1 comma 1, strictly decreasing. So this is the 6th question.